Yesterday we looked at the rational equations in which we had already set up in a proportion form. So all we had to do was cross multiply. On this one, we're going to have to do a little bit more work before we do that. Not getting a common denominator, but recognizing a denominator and then eliminating denominators and then working from there. Well, let's just jump into a few examples here. First one we're going to look at right here, we can see, first off, we're going to just jump to this and state our excluded values. Our excluded values are anything that makes the denominator equal to 0. On either side, that excluded value is 0. If I were to plug in an x value, the one that would make it 0 would be x equal to 0 on either accounts. And then the 4 is nothing. So this is an excluded value. X cannot be equal to 0. So we can, as we can see here, what we want to do is eliminate denominators. And we can do whatever we want in math as long as we do it consistently. So if I wanted to get rid of this denominator, what I would have to do is multiply each term by x. And notice I said each term by x, so I'd have to multiply times x times x times x. But we're going to do more than that because that would eliminate our denominator right here, and it would actually eliminate the x from this section here, but there would still be a 5. Now the 5 is not a real big issue, but if you're like me, you'd rather not work with a common or with a denominator at all. So what we're going to do is when we multiply times our x, instead of multiplying times x, we're going to multiply times 5x. And we can do that as long as we are consistent in our multiplication. So we're going to multiply everything times 5x instead of x. So when I said it's similar to a common denominator, this is what I meant. We didn't get a common denominator, but it's the same principle as getting a common denominator. So we see that the 5 does not cancel here, so here's another important portion. Anytime you have these binomials, make sure you put parentheses. So now my 5 does cancel my denominator, so I'm no longer dealing with denominators in any form or fashion. I'm going to rewrite this before I go distributing. You are welcome to distribute where they are in place, but from our first set of parentheses, the x is gone, but the 5 was still there because it didn't cancel, so that's going to have to distribute to both of those terms. On the second term, we have a subtraction sign, therefore we're going to keep the parentheses. Even though we canceled both the 5 and the x, we still have a subtraction of a binomial, so we need these parentheses. And on the other side, we have 4 times 5, 20, with an x. So now we've gotten rid of the rational expression because we have no variable in the denominator. So we're going to continue on here. And this is a distribution. 5 times 3 and 5 times 5. We're going to distribute the -1 inside. That's usually where the mistake takes place, by the way, so make sure that you're paying attention. If you forget the parentheses here, you're only going to give the negative sign to the x, and you're going to ignore the 7, which is not what we want to do. All right, from here, we're going to combine like terms. So that makes 14x. 25 minus 7 equals 18. I'm actually going to subtract the 14x over to join the 20 because I like to have positive variables, and that will keep those positive. So 6x equals 18. We divide both terms by 6, and our solution is x equal to 3. And 3 was not one of our excluded values, so 3 is an acceptable answer. We can always plug that in and check our answers, but we will later learn how we can graph this thing. And that's also another really good method to getting answers. So we'll take a look at that. So the next example is very interesting. I'm going to go ahead and take my denominator down to the bottom and establish that x cannot be equal to 5. And again, that's just me setting that equal to 0 and solving, so we are excluding the value 5. But the reason why I say this one is interesting, because we have a common denominator here. My suggestion to you is anytime we do have a common denominator, go ahead and get those values to the same side. So I'm going to take this entire expression right here and move it to the other side with the subtraction sign, just like you see here. I'm going to rewrite this, even though we can probably do this with some mental math. But what this would look like is 5x over x minus 5 minus 1 over x minus 5. That's what that would look like on the other side. Now, remember, when we're dealing with rationals, they act the same way that fractions do. So let's think about this for just a second. Just take a little side trip here. If I had 3/3 minus 2/3, what we do is we do the math for the numerator and leave the denominator alone. The same thing is true with rational expressions. Remember, if you're never certain, check and just ask yourself, what would a fraction do? So in this case, what we end up having actually is 5x minus 1, because these do have a common denominator, over x minus 5. Now, what we have established here, what we've created, is the proportion look, just like we had yesterday. Because the left side is a fraction as well, because what you got to remember is that 3 is 3 over 1. So I'm going to go ahead and fix this little issue here and put some parentheses. And we can do the cross multiplication here. So I'm going to go 3 times x and put my result here. 3x minus 15. Again, mental math. We've gotten to the point where we can do some of that there. If I've lost you, speak up. I'll be happy to explain what I did. Equals 5x minus 1. Again, I like to let my big variable pull the small one. So that would be the 3x. And on the contrary, I'm going to move the 1 over to the negative 14. So we end up with 2x equal to negative 14. We then divide both sides by 2. And x should equal negative 7. Negative 7 is not one of our excluded values, so it should be an answer that we can accept. And again, we would check that answer, negative 7, just to make sure that it worked, but I'm telling you now, just for time's sake, that negative 7 is an acceptable answer. So on this one, we have a couple of things we could do. One of these denominators are actually really close to having a common denominator, but they're not. I wouldn't spend too much energy trying to get that common denominator, but one thing we definitely need to do is we need to start by factoring. This is the first time we've had the opportunity to factor, so we're going to do that. We need that for 2 reasons. We need to first state our excluded value, and we also need to find what our common denominator, so we can kill it, will be. All right, so here we go. We see that I've already factored out the x. We had x squared minus x, so obviously we can factor out an x. We have 2 denominators, and we need to make sure that these denominators don't become 0. So what causes x minus 1 to become 0? would be if x were equal to 1. So we will reject any x minus 1s. It's an excluded value. So not only will we reject it, we can't even put that one in. And then the other one would be x equal to 0. So we have two excluded values on this one, 1 and 0. Okay, so what we're going to do on this one is we are going to just kill the denominators. It's going to be a good bit of work trying to get the common denominator and trying to get this in the proportion method. So we are just going to kill the denominators. All right, so way you do that is you just multiply by what's there. So what we need to eliminate here is an x. We're going to multiply everything times an x. That will get rid of the x. And we also need to get rid of the x minus 1. Now the x minus 1 is going to get rid of each of these. So we don't have to write it twice. So we just keep piling on those denominators because we want the denominators to go away. So let's see how this works. First off, let's see what cancels here. Canceling x and an x. X minus 1 cancels x minus 1. So on the right side, all we have, so what we have left here is just the 1. I'm actually going to skip the 9x for just a second and go over to the other side while I'm in a canceling mood here. So we see the x minus 1 is going to cancel the x minus 1. And all that's left up there is an x. So this would be x times x squared. All right, now let's take a look at all of this. I'm going to rewrite all of this, but this is also one of those spots where if you feel comfortable, you can do this work as you move it, but this is what we end up with. That's what I have highlighted there. That's just the rewrite. So we are going to distribute, in this case, a positive 9. So distribution going to the inside there. So what we end up with, I'm going to carry down the x squared. 9x times x is 9x squared. 9x times negative 1 is negative 9x. And then the equals 1 is just carrying down. Any like terms need to be combined. It looks like I've got the x squared and the 9x squared. So what we end up with is 10x squared minus 9x squared. So we got a quadratic. So I'm going to go ahead and move the 1 over because we know regardless of what kind of solving we're going to do, we're going to have everything to one side. At this point, you do whichever method you feel comfortable at this point. Like I said earlier, we are kind of beyond the point of discussing factoring or quadratic formula. You decide what's best for you. But remember your options. You can factor, you can use quadratic formula, you can graph and see where it crosses the x-axis. Right? This one is not terribly hard to factor. Factors of 10 that can become 9. If we use the master product method, what we end up with, or the AC method as we refer to it a lot of times, is this. Remember, we're looking for the factors of 10 that can become 9. Well, that would be 10 and 1. So that's how we get down to that. Again, use the quadratic formula. I don't care. Graph, that's completely up to you. We're solving anyway, so if you use the quadratic formula, it's going to not only factor it for you, it's going to give you the actual solutions. So remember, the two solutions come from the parentheses. We're going to set this equal to 0, and we're going to set this equal to 0. So we subtract 1 from this side, and we divide by 10. So one of my solutions is x equal to negative 1 over 10. That was not in our excluded values that we had up there earlier. So we would have to put that in to see if it works. But really, whatever we graph, if we see it touching, then it's a solution. Now, here's what we do run into. On the other side, we end up with an x equal to 1. This answer I am rejecting because this is an excluded value. There's no need to plug this in. We have already established not only can this not be a solution, we can't even plug that value in. So that is a rejected solution. So the solution of this one and that is actually only -1/10. Right, here we've got another one that does something interesting. I'm going to start this thing off by stating excluded values. X cannot be equal to -1. X cannot be equal to -3. Regardless of what happens in this example, that cannot happen. Now, if you'll notice what I told you I like to look for, we've got a common denominator here. So we can actually set this up in proportion form, and we can even do one better in this particular one. Let's see what happens. So just like on the last example, what I'm going to do is I'm going to move this over, and since there's a minus sign, I can add this over. So here's a rewrite with moving that to the other side. Would be 3x plus 3 plus x over x plus 3. And we have a common denominator, and here's the interesting that happens here. What we end up with is common denominator x plus 3, obviously. And then we have x plus 3. It would technically be 3 plus x, but we can use the reflexive property, the reflexive property, and rewrite that. And it ends up looking like that. So what we have actually is 1 on the right side. So we have 2x over x plus 1 is equal to 1. So we are going to do the proportion method because we have this set up. I'm going to change that to 1 over 1. So I'm going to work this way. We're going to go 2 times x, that would be 2x. And we're going to have equal to x plus 1. We subtract our x from both sides, and x equals 1. 1 is not the excluded value, -1 is, so this is an acceptable answer. If you had not canceled these, you end up getting quadratic equation with canceling happening, and you actually get a solution of -3, which is an excluded value anyway, but when we canceled it, we eliminated that excluded value as well. So that kind of worked in our favor in multiple ways. All right, the last example. Save the best for last, obviously. So we've got a lot going on here. But before we can do anything, anytime we have an opportunity to factor, we need to do that. So I'm obviously talking about the denominator in the right side here. I need the factors of 30 that can become 11. -11, actually. So that would be x minus 5 and x minus 6. Well, that worked out really nicely for us because that was actually the two terms that we've already seen. So this is going to work out a lot easier than it could have possibly been. But let's go ahead and go over to our right and state our excluded values. We cannot have a 6 as a solution, and we cannot have a 5 as a solution. Now we have a repeat on this side telling me 5 and 6. We're not going to write the repeats. So, and I'm also not going to rewrite this. This becomes a bit of a mess here. So what we're going to do now is just start killing denominators. Kill them one at a time, all at once. It doesn't matter. So I need an x minus 6 to cancel this. So I'm going to multiply times x minus 6 times everything. So I got that one off the list. This one wants an x minus 5, so I'm going to multiply times an x minus 5. And this is actual multiplication. This isn't times top and bottom. This is only being multiplied times the top. But what we will run into is cancellations of these values. So, and again, there's an understood parentheses around each of these terms as well. So we're going to cancel anything that does cancel. So like in this case, that would be x minus 6 canceling x minus 6. In this particular one, it's the x minus 5 canceling the x minus 5. And in this one, it's actually both. Both of those are being canceled out. So the right side's really easy. Everything canceled, so the only thing we have left is the numerator, which was 1. Highlight here so we can maybe state with colors. This little section here, the x minus 6 has gone from the top and the bottom. So all we really have here is x minus 5 times 1. Well, x minus 5 times 1 is x minus 5. I'm dropping the parentheses because the next thing is a plus sign. If you kept the parentheses, there's nothing wrong with that. All right, now let's take a look at this middle section here. So we canceled out the x minus 5s. We do, however, have x minus 2, which is a binomial. So it's very important that we keep it a binomial. And I'm going to need a little space here for this one. So I'm going to move this stuff out of the way for a minute. Or move it over, not out of the way. And we also have the x minus 6. And I'm going to stop and let that one sink in for just a minute on what exactly happened there. Since the numerator was a binomial and it's being multiplied times a binomial, we've got to have both of those in parentheses, and we're about to have distribution. Let's go ahead and take care of that distribution. X times x, of course, is x squared. X times negative 6, negative 6x. 2 times x, positive 2x. And 2 times negative 6 is negative 12. So we've got a quadratic happening again. So we know we're going to need to get everything to one side, but let's go ahead and combine our like terms. So the x squared doesn't have anything like it, so I'm going to just go ahead and put that to the front. I like to mark these things as I go so I don't lose anything. I have an x, a negative 6x, so that together makes negative 5x, plus 2x makes negative 3x. I have a negative 5 and a negative 12 that are on the same side, so that makes negative 17 equals 1. But again, we've got a quadratic happening here, so everything needs to be one side. So when we're finally done with all this, we end up with all of that. And again, at this point, you do what you know to do. If that means using the quadratic formula, you can do that, and this will actually go straight to solutions. If you are more comfortable factoring, if you're good at factoring, take advantage of it. This actually factors down to x minus 6, x plus 3. Meaning I have solutions at x equal to 6 and x equal to 3. Do you notice anything? Now, if you were to graph this, your graphing calculator is not going to let you make this mistake. If you will look at the table, it will not let you make this mistake, but you've got to put it in a situation to do that. So remember, we started this problem off stating that x cannot be negative, or excuse me, x cannot be 6. So if x cannot be 6, obviously the solution can't be 6. So we reject the answer 6 and we accept the answer. I have 3, but that's wrong. It's -3. We have a solution -3. We have a solution -3, which is not rejected. So that would be our single solution on these. Now, in case you're wondering, you can have both solutions get rejected. You can have neither solution be rejected. So just be prepared, be prepared for any of those to happen. All right, good luck.